as we move to the second section of fractions, I want to ask you the question of, can we add 1/2 and 1/3 together, and why or why not? So to answer this question, I actually took 1/2 up here and 1/3 down here, and I'm going to try to just place them together and see what happens. I know that if I moved this piece down, whoops, right here, I end up getting a little bit of an overlap here. And so what I end up getting is 1/3 plus a little bit more than 1/2. So that doesn't really work. Let's try if we move it back up. Let's see if we undo all of this here. What about if we move this piece up? Well, now we have 1/2 plus 1/3. That doesn't really work either. And so you might have heard before that you need something called a common denominator. And if you remember from the last section, the denominator is the bottom part of the fraction, so the 1/2 or the 1/3. What a common denominator means, and this is something you have to have lasered into your head, is that both fractions or all fractions are the same size. That is absolutely necessary in order to add or subtract fractions. So, when we move on to the next fraction, we have 3/4 minus 1/4, which is asking us to start with 3/4 and to take away one of those fourths. Now, because these fractions have a common denominator, or more specifically, the fractions are the same size, what we do is we can actually take this 1/4 and remove it from the top. So 3/4 minus 1/4 is equal to 2/4. Now, we know from the last section that 2/4 is the same thing as 1/2, because if we remove this line and this line over here, we end up getting 1/2 here and 1/2 over there. Or, if you're using the algorithm, you can divide the numerator and denominator by the same number. So 3/4 minus 1/4 is equal to 2/4, which is the same as 1/2. And we could do that because the fractions were the same size. But what if we have this problem down here, very similar to before, but not exactly the same? We have 3/4 minus 1/2. Once again, we want to take away. Well, the problem here is we can actually take away one box, but that doesn't work now because this box is bigger than each of these. Therefore, we need to turn our halves into fourths, which we did before. Move that down here. So 1/2 is the same thing as 2/4. So now the problem becomes 3/4 minus 2/4. So I take away 1/4, 2/4 from each, and I am left with 1/4 left over. And 1/4 is in simplest form. It cannot be simplified at all. Therefore, we are done. 3/4 minus 1/2 is equal to 1/4. Now, the last problem that we're going to work on is the same idea, 3/4 plus 2/3, and we need to figure out the answer. Now, on the top part here, we have 3/4, and on the bottom part, we have 2/3. Let's keep our color coding lined up here. Now, the problem with both of these is we can't turn one fraction into the other. There's no way to turn thirds into fourths, so we have to find a common denominator, or the least common multiple between these two numbers. Now, I know there's a couple different ways to do this. I like to think of multiples of each. So I'm going to go, let's go a pen here. So I like to go 4, then 8, 12, 16, 20. Those are some multiples of 4. And then some multiples of 3 are 3, 6, 9, 12. Oh, look at that. We got a denominator of 12. So we're going to turn both fractions into something over 12. Okay? So, to turn fourths into twelfths, I have to cut each piece into 3 pieces. And so that's what I do right here. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. And on the bottom, to turn thirds into twelfths, I have to cut each piece into 4 equal pieces. Or what I like to do is I go to sixth, and then I cut each sixth in half. So now, once again, these do not line up perfectly, but they line up pretty close. And I have 1, 2, 3, 4, 5, 6, 7, 8 twelfths. And now we're trying to add these together. So what I'm going to do is I'm going to fill up these 3 here. I'm going to remove 1, 2, 3. Now I'm going to re-put the lines in so that we don't completely throw ourselves off here. But I took away 3 of those twelfths, and I put them up here on the top. Now let's do it in blue. 1, 2, 3. So there's 2 ways to do this problem. Since we have common denominators here, 9 twelfths plus 8 twelfths is equal to a total of 17 twelfths. Okay, that is our improper fraction. But if we look at this problem, we actually have one whole number, and we have 1, 2, 3, 4, 5 left over. Now, you might have seen this before. It would have been a while ago. Both of these are correct. The way we think of this is we think, how many whole numbers can we pull out? A whole number is equal to 12 twelfths. And 12 twelfths plus 5 twelfths is equal to 17 twelfths. Therefore, 17 twelfths has to be the same as 1 and 5 twelfths. As always, if you have any questions, make sure you let me know. If you didn't get 3 out of 4 or 4 out of 4 on this problem, make sure you do the video retake. Otherwise, you can pick your next assignment in the choice board.